All right, now that we've worked on graphing radical equations, we're going to start looking at transformations of those equations. So today's title for the notes will be Transformations of Radicals. Okay, so make sure you put today's date somewhere in your top right-hand corner or top left-hand corner, depending on what kind of page you are on your notebook. So let's remember that for square root functions, our parent function was y equals the square root of x. That was just the basic shape of the form of the graph that we're used to seeing. Today we're going to look at what happens when you have numbers underneath the square root and numbers outside the square root and how that changes your graph. So we're going to take a look at the parent function and then describe some changes to it as we're working on them. So at this point you're going to want to type in the graph for the square root function, which is the one that looks like this. So this is the equation for the general square root function. So we're going to take a look at what happens if we do some things to some parts of the equation and see what happens. So let's say what happens when I graph underneath the square root y equals x minus 3. For this, I'm going to pull up Desmos, and we're going to compare on the graph with Desmos. So for Desmos, remember if you go to your web browser and you go to desmos.com, you'll get this screen. You're just going to click on Start Graphing. So what I want to look at is I'm going to type in my equation y equals, and we're going to press this keyboard key down here, and we're going to look for the square root symbol. So there's a square root symbol. X, that's my parent function that we've seen on the graph already. If I zoom back into that graph, that's the parent function we have there. But now let's type in another equation, y equals square root x, and then we said minus 3. All right, so let's take a look at what happened here. So this is my parent function, and then here's my new function. So really it looks like what happened is that this shifted to the right. I'm going to zoom in here. 3 spaces. So this whole graph shifted right 3 spaces. So I'm going to sketch that graph on here. I'm going to use a different color, so you should have colored pencils. And we said that this one shifted 3 units to the right, and then everything else stayed the same. So shifted right 3. And I'm going to put a little color next to this one so I can remember that was orange. And then I'm going to write what happened. Shifted 3 units right. Okay, let's look at another example. This time let's do a plus underneath, and we'll do x square root of x plus 4. So again, we're going to use the same graph, and we'll use Desmos to see what happens when we shift it, x plus 4 underneath the square root. So on my equation, I'm going to keep the parent function because I want to compare, and I'm just going to change this one to plus 4. And then let's zoom in and see what happened here. So this time, here's where I started. This time it looks like it's shifting 4 units to the left. Everything else stayed the same. in terms of its shape, it has shifted 4 spaces to the left over here. So I'm going to graph that. I'm going to use a different color. We went 4 spaces to the left. 1, 2, 3, 4. Highlight that one for black. And then we'll write down the shift. So it shifted 4 units left. Some of this might be familiar from first semester when we talked about transformations. We're just applying it now to the square root functions. All right, let's try another one. This time, notice how I'm going to write the square root of x, then on the outside of the square root, I'm going to put plus 3. So the outside now has a value of plus 3. So let's see what happens, and you might be able to predict if you remember from last semester. So I'm going to delete this one. Square root of x, and I said plus 3 on the outside. When we look at what happened here, this time the graph stays the same shape again, but here it looks like this time we're moving up. 1, 2, 3. So I'm going to sketch that on my notebook, and then we'll use a different color. This time I'll use purple. So we're going up 1, 2, 3. And this one shifted up 4 units. Or excuse me, 3 units. Let's take a look at 2 more types of transformations that we'll look at, and we'll probably be able to predict these now. So we'll do the square root of x minus 4. And again, notice that the minus 4 is outside of the radical sign. So on our Desmos, we can get rid of that one and type in a new one, square root of x minus 4. And notice I had to shift out of the square root to kind of see what happens. Let's take a look at this one. Remember, red is the original. So it looks like for this one, I went down 1, 2, 3, 4 units. So this one is shifting down 4 units. So we'll use a different color for this one. Went down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It still has that same shape, it just went down 4 units. And that's just describing the transformations of the graph based on what's happening in the equation. So with these numbers, you can tell me right away without having to graph, oh, x plus 4 underneath the square root, that means it went 4 units left. Plus 3 on the outside means it went up. Minus 4 on the outside means it went down. And then it tells you how many numbers it went down. One other type of reflection or transformation we haven't talked about is when you have negative numbers. So if I put a negative number in front of the square root symbol, let's see what happens. So we'll delete this information, and I'm just going to put a negative sign in front. So with a negative sign in front of it, Remember, red is the original. It looks like it just flipped it over the x-axis. So with the negative sign in front, it flips over the x-axis. So I'm going to use a different color to graph on my sheet, and then we can describe the transformation there. Use this light blue. And that shifted it over the x-axis. So reflected over the x-axis is the official words. So those are the transformations of a graph with a radical function. It follows the same rules that we learned first semester, so this should hopefully be a review. Let's kind of summarize here at the bottom as our last piece, and then you can start practicing with the practice questions. All right, so summary. Here's our general equation for a square root. Y equals something times the square root of a number plus or minus a number underneath it, and then plus or minus a number on the outside. So we can break these down now based on what we just worked on. If a is negative, if the value in front is negative, the graph reflects or flips over the x-axis. And that was that light blue graph we had. For numbers on the inside, it's the opposite. So if you're underneath the square root symbol, if you're contained or within the square root, you do the opposite. So if adding, you shift left. If subtracting, you shift right. And then for the k value, that's the one that has the movements that go with what we're used to or what we would expect. All right, so if adding on the outside, you shift up. If subtracting, you shift down. So on the outside, when the values were on the outside, positive meant you went up, negative meant you went down. On the inside, positive meant you went to the left, and negative meant that you went to the right. So it's a little backwards than what you're used to. And that's just transformations of radicals. You should be able to practice now with these problems.